All right, let's jump right into this explainer. Think back to when you were a kid and it was time for a class party. Usually, planning meant a totally chaotic chorus of wild guesses, popular votes, and ultimately, someone crying because the pepperoni ran out. But what if we took that chaos and transformed it into a precise, data-driven math mission? Well, today we're unpacking a really incredible third-grade lesson plan called the Pizza Party. It's essentially a 3-day mini-mission where the students become the actual party planning crew. They have to make real decisions with real numbers, and most importantly, they learn to let the data, rather than their own assumptions, make the call.
So here's our roadmap for this mission. 1. Planning with real data. 2. Day 1. The budget order. 3. Day 2. The surprise. 4. Day 3. The whole grade. And finally, 5. Grading the real thinking.
Okay, part 1. Planning with real data. Every good mission needs a solid briefing, right? And before they can order a single slice, our third graders really need to understand the constraints they're working within.
What's great is how perfectly these baseline metrics mimic real-world event planning. We've got a class size of 24 students, we know each student is going to eat about 2 slices, and each pizza has exactly 8 slices. We've also got our price list. Cheese is $9, pepperoni is 10, and veggie is 9. So right off the bat, this requires the kids to use multiplication, division, and addition just to figure out the sheer volume of food they need, and that's before money even enters the picture.
But here is the absolute twist that makes this lesson so effective. It's not just about raw math, it's about context. The students are handed historical behavioral data from the last party, and that data tells them pepperoni runs out, veggie gets wasted, cheese gets overordered. This right here, this is the secret ingredient of the whole framework. It literally forces students to use judgment. They can't just crunch the numbers in a vacuum. They have to balance their math with actual human behavior.
So with the ground rules set, let's move right into part 2. Day 1, the budget order.
The goal for day 1 is pretty straightforward, but definitely constrained. The kids need to figure out how to feed all 24 students, and they have a hard, non-negotiable budget limit of exactly $60.
To pull this off, they have to navigate a specific 3-step workflow. Step 1 is the pure arithmetic. 24 students times 2 slices means 48 slices are needed in total. 48 slices divided by 8 means they need exactly 6 pizzas. Step 2 is where it gets really interesting. They have to pick the mix of those 6 pizzas and make sure it costs $60 or less. And then step 3 is the kicker. They have to write out a defense of their choice using the numbers and that vital historical data we just talked about.
Now, before we look at the results, I want you to really think about this for a second. What do you anticipate is the natural pitfall a group of 8- and 9-year-olds will fall into when they're deciding which pizzas to buy for their friends?
Well, the trap is ordering 6 cheese pizzas simply because it won the popular vote, or honestly because it's just the easiest math. At $9 each, 6 cheese pizzas cost $54. Hey, it fits the budget. But it completely ignores the data telling them that cheese usually gets overordered. A strong sample answer, on the other hand, actually takes the data into account. 3 pepperoni, 2 cheese, and 1 veggie. This mix totals $57, so it's comfortably under the $60 budget while directly addressing the fact that pepperoni is the favorite and veggie is the one often wasted. That is analytical thinking in action.
Okay, now that they've mastered the baseline, we reach part 3. Day 2, the surprise.
Here's where a massive curveball gets thrown. Suddenly, 6 more students arrive. To help out, the teacher adds $25 to the budget. Now, since they spent $57 on day 1, their new budget limit is exactly $82. The challenge? They have to rework the entire order without wasting food or money.
So ask yourself, how do people normally react, especially an 8-year-old, when a bunch of unexpected guests just suddenly walk through the door hungry?
The overwhelming urge? Absolute panic. The trap here is panic ordering 4 or more extra pizzas just to be safe, which wastes a ton of money. Another common trap is adding a veggie and a cheese just for variety. But the strong sample? That relies 100% on the data. 6 extra kids need 12 extra slices. 12 slices divided by 8 means 1.5 pizzas. So naturally, you have to round up to 2 pizzas. And what kind should they be? The historical data literally tells us pepperoni is what runs out. By surgically adding just 2 pepperoni pizzas for $20, the new total is $77. It's safely under the $82 limit, and it perfectly satisfies the sudden demand.
All right, which brings us to the big finale. Part 4, Day 3, the whole grade. This is the ultimate escalation. All 3 third-grade classes are joining forces. The students need to take their super successful 8-pizza plan from day 2 and scale it up for the entire grade, keeping the total cost under a brand new, massive budget of $250.
So they know they need 8 pizzas per class, right? And there are 3 classes. So 8 times 3 is 24 pizzas total. If you have to order exactly 24 pizzas, what's the absolute most tempting mathematical shortcut you could take?
Yep, it's the 8 of each trap. 8 cheese, 8 pepperoni, 8 veggie. It feels incredibly even. It's super easy to calculate and it just sounds fair. But doing this literally triples the veggie waste and vastly underorders the pepperoni. The strong sample answer requires students to multiply their proven data-driven mix from day 2 by 3. That yields 15 pepperoni, 6 cheese, and 3 veggie. It costs $231, keeping them nicely under the $250 limit, and it keeps that delicate, data-based balance completely intact.
Let's shift gears for our final section, Part 5, Grading the Real Thinking.
Take a look at the differentiation built in here. On one hand, you've got this clean, super efficient teacher answer key. But on the other, you have scaffolded student pages. For learners who might need a little more support, the key arithmetic numbers are pre-filled, and they're provided with sentence frames to help them articulate their reasoning. The actual critical thinking part, deciding which pizza to order and why, stays entirely with the student. It just proves that differentiation definitely doesn't have to mean dumbing down the logic.
So how do you actually grade an assignment where multiple different pizza mixes could totally work? Well, the rubric handles this beautifully. It isn't just looking for one single correct answer. Instead, it assesses 4 specific criteria. Is the math correct? Did they use the historical data? Did they avoid waste by not vastly overordering? And crucially, did they defend the call by explaining their choices with the numbers? It's assessing their actual reasoning.
And of course, this whole framework aligns perfectly with mathematical practice standards. By interpreting data to make a decision, reasoning quantitatively, and modeling a real-world situation, these students are actually building and defending mathematical arguments from hard evidence. They aren't just solving equations on whiteboard, they're applying math to real life.
I want to leave you with this final, really powerful capstone reflection question that's asked of the students. Give one example where the math changed what you would have guessed. It's a lesson that goes way beyond a third-grade pizza party. It honestly makes you wonder, where else in our adult lives should we be letting the data, rather than our assumptions, make the call? Thanks so much for joining me for this explainer. I'll see you next time.